Hello there. So I'm going to walk through that credit card problem that we have. Now, we are high school seniors, we're working through things. I want to talk to you a little bit about money. You're going off to college. Typically your answer for why are you going to college? Because I want a good job, because I want a high paying job, because I want to make some money. Okay, so you understand that money is important. Now there's two sides to money. There's getting money, there's paying money. That's all there is to it. You want to get more, you want to pay less. Now the two formulas that we've talked about so far are systematic savings is the way to get money, to acquire long-term money. And that was the whole idea that Let's Invest project, where you're looking at your possible income someday, your average salaries, and how to save. I'm going to come back to that in a little bit later with a different video just to kind of talk through my thoughts and kind of give you some idea about what to think about. That formula was all about the getting the money part. The second formula, the amortized loan formula, that's all about the paying money part. You're going off to school next year maybe. You're going to pay some money, student loans. You're going to go, ooh, credit cards. On your college campus, there's going to be tables set up. Free t-shirt if you sign up for a credit card. That's one less day that you've got to do laundry. Fantastic. Anyways, 18 shirts later, you've got credit cards. Credit cards, free pizza. Why not? I don't have to pay for it right now. Wings, trip to the Keys. Fantastic. You're going to have to pay for that someday. Your mortgage, your credit cards, your car loans, your home equity loan, your any kind of personal loan follows this second equation. Now, if you understand how it works, you can actually save yourself a little bit of money. You can understand where your money is going. You can help yourself budget. So that's all you need to know for your financial life. Getting money, the systematic savings formula. Paying money, the amortized loan formula. So, bird flew just overhead. So now we're going to take a look at that credit card problem. I'm going to walk you through kind of solving it and how we think about things, as well as point out some other ideas. I'm going to switch over to that now. So here we've got Parker. Not too surprised about this one. Parker makes a lot of friends during his first semester of college. He maxes out his credit card while buying $3,000 worth of pizza. Credit card charges 21% interest compounded monthly and requires a minimum monthly payment of 2% of the initial principal. These are real numbers. Pay attention. Now 21%, me, somebody that's an established adult, has great credit. I get 21%. Your first credit card, you're like 27, 28%. Pay attention to the numbers. But these are real numbers. So going through things, we need to identify the different pieces. Now, this is a credit card, so we are paying money. That's how much we owe, is our $3,000. That's our principal. We've got an interest rate, 21%. We are compounded monthly, so our end value is 12. Blah, blah, blah. It doesn't tell us anything about time, but if we read through the questions, okay, how long? Okay, we're asked for a time. What's our minimum monthly payment? What's the R value? Well, it's saying that 2% of the initial principal. The initial principal is our $3,000 up here. 2% of $3,000, that's going to get us $60. So I've identified all the components to my formula. Now we are using our amortized loan formula because we are taking a loan. A credit card is a loan. So we've got our formula. We're going to take our information, substitute into the formula. Now we need to solve for t. Now what I notice is t, the variable, is up in the exponent. We're eventually going to need to take a log of that. So we need to move everything away from that variable in the exponent. So I'm dividing by this 0.21 over 12. I'm going to move that to the other side by multiplication. I'm multiplying by 60. I'm going to divide that to the other side. Now I've got this on the left side, we've got the right side 1 minus. I'm going to subtract and add to swap those sides. Otherwise, we're going to come up with a negative value. I'm keeping all my numbers as is so that you can see where each piece comes from rather than plopping things into the calculator. I'm going to use the calculator at the very end. So now I'm going to subtract, I'm going to add. Swap my two sides of the equation. The reason I do that is because now my left side, this is a positive number. My right side, this is a positive number. We cannot take a log of a negative number, so we need to do something to make it positive. Notice we would have a negative equals a negative otherwise. Now that the outermost piece is that variable up in the exponent, here's where we put in the log. We take a log of both sides. We're going to use properties of logs, that the exponent inside of a log comes out front, turns into multiplication. And so now we've got negative 12 multiplied by t, multiplied by log equals a log. Solving for t, we're going to use division to move everything over to the right side. So we've got t, and now plugging things into the calculator. Notice I put an extra set of parentheses here. That's what I need in the calculator. So I'm log there's my entire numerator divided by extra parentheses, grouping, negative 12. All right, 9.98. So we've got about 10 years. So if we pay the minimum balance, it will take us 10 years to do that. And so we could see that, okay, the total payments, we're doing $60 every month for 10 years. That's going to be a total of $7,200. There we go. Those are real numbers. One big splurge, one vacation, spring break, 10 years to pay that back. Total payment you can find, $7,200. Getting that, we're doing $60 every month for 10 years. If we subtract our principal, we see that over on the right, we paid $4,200 in interest alone. That's money just for the opportunity to borrow up ahead. That's where credit cards, that's where loans really get you. Banks make their money off of the interest. Going on to the second part. Here, asked to be finding something a little bit different. After graduation, what is our remaining principal? Realize, okay, maybe we got some graduation money. We saved up. We need to pay this off. Instead of taking the full 10 years, it is 4 years later. We want to pay it off. We want to cut 6 years off of our loan. How much do we still owe? So identifying the pieces that we know. The principal we're trying to find. That's the remaining principal. Remaining principal requires remaining time. We're paying $60 a month. Interest rate is still 21%. We are paying monthly. Time remaining is 6 years. So 10 years total was the initial time. 4 years have passed. There are 6 years remaining. So I can take that, still using the formula for the loan. I'm going to substitute all the values in, and I notice everything is on the right side, so I can go to the calculator and evaluate. And it says $2,445. So we still owe $2,445. Think about what that means. We started with a principal value of $3,000. We started with a principal value of $3,000. We still owe $2,445. So after paying for 4 years, $60 every month, we have paid $60 every month for 4 years. We have paid a total of $2,880, but only $554 has come off the principal. That means we have paid already $2,300 in interest. Almost the full balance of the loan has gone to interest already. Those are real numbers there. And here's where credit cards get you. Now what's happening here is that the very first month you pay your $60. Well, your $60 covers the interest that's built up. 21% interest on $3,000 for 1 month. Let's do that. We've got $3,000 just compound interest. But we've only done it for 1 month. That $3,000 turns into $3,052. Now you have paid $60, which means you have covered $5,250 in interest, and only $7 has been taken off that $3,000 principal. So next month, the principal is down to $29.93, and it would go through compound interest again. So each month, you are covering the interest that builds, and then any little bit of principal that you can take off. We can look at what's called an amortization schedule, and I've got one of those prepared already. If we are paying $6,000, now I just went and Googled amortization schedule. We have a loan of $3,000. We know that it's going to take 9.9884 years, 21% interest. So we have a $60 payment. Each month, we can see how much we're contributing. So out of our $60 that very first month, $53 is going towards interest, or $52.50, and $8 is going towards principal. Balance, $29.92. Next month, $52 is interest, $8 is principal. Next month, $52 is interest, $8 is principal. So over 4 years, well, you've actually only paid $8, $8, $8, $8 a month. You're only paying that towards the principal, where most of that is interest. Over time, it builds up the principal, and the interest is reduced so much that over time, it flops. So like the last few months of your loan, you'd be paying $4 in interest and $56 in your principal, $3 in interest, $57 towards your principal. And this chart up here gives you a different idea. Very first year, you pay only $63 in principal, but you've paid $416 in interest. And it's slowly whittling away, paring down your principal value. That's why credit cards, that's why your mortgage, that's why your car payments, your student loans take so long to pay off. Be aware of that. There are 2 things that you need to know for money: how to get money, how to pay money. If you understand how to pay money and reduce your costs, you can save yourself a lot more, which means your getting money bit is going to be even bigger. Then you can afford to go out and do other things, and you can budget and make sense out of it. So there you go. Try it out. I'll get something else up soon. Take it easy.